Hi there, everybody. Welcome back. So today I've got another chalk and talk for you, and we're going to talk about testing. So testing means different things to different people, especially in the data realm, where we might be talking about testing of the code that we're producing. We might be talking about testing of the actual data, data quality, data mastering, all of that good stuff. And so I just wanted to put a video together to make sure that everyone is clear on where the testing is, what's the trigger for that testing, why we're doing it, what's happening, all of those kinds of things. This hopefully will then make it easier when you're having a conversation around data testing to specify exactly what you're talking about, which system should be doing that testing, and who should be responsible for it. This is quite a big sort of issue when we introduce testing to customers, because quite often one person will be talking about data quality testing, someone else will be talking about DevOps, and then there's a bit of a clash as to who's talking about what and why they're talking about that. And then you end up burning just weeks of meetings talking about these things when it's sort of unnecessary. If you just scene set at the start of these conversations, then it's much easier to everybody get going in the right direction from day one. So with that, I'll switch over to the whiteboard and kind of talk you through what testing happens throughout the entire life cycle of your data ecosystem. I will probably miss some things, but hopefully you can fill in the gaps of anything that I do skip over, and hopefully that will make sense. So with that, straight to the whiteboard. And I'm going to start off with the actual development of the thing. So we'll be creating some sort of code here to do something. And when I say code, this could be any of your kind of deployable assets, your database, your data warehouse, your scripting, your Python libraries, all of that stuff, the things that people work on. So we're going to start in the development environment, and where we write the code, we're going to end up doing some sort of unit testing. And the purpose of unit testing is to make sure that the code that you've written actually does what you think it should be doing. So this can be something like if you've got a library with a function in it that is testing, that is adding two numbers together. So we're going to do a unit test that will put two numbers into that and tell us whether it's giving us the correct answer. We might also put one number and one string, and it should give us an error. And that again is another unit test, and you'll have hundreds of these to test every aspect of your code with good and bad data to make sure individually that piece is going to work properly. And each developer is going to create their own unit tests. Ideally, they'll create those before they actually start doing the coding of the other things. So this is known as test-driven development. You create your test, then you write some code. It should pass the tests. When it does, you commit it, and you're finished with your work, and everything should work as expected. That obviously in the real world, that isn't the way that these things happen, but that's the dream that everyone talks about. That's the marketing view of testing. So then we're going to commit the code, and we're going to do some integration testing. And these tests just bring more things together, test them against one another, to make sure my code works with your code, and so on and so forth. And I'll probably do another video about integration fairly soon. So following on from that, we're going to do some end-to-end testing. And this is just to make sure that the whole pipeline is going to run. So we will do that testing against a known set of data. We'll run that set of data. I talked about this in a previous video, to make sure that we get the results expected against a representative data set. We'll also do some performance testing. And these are kind of operational tests so that you understand how well it's going to perform, what infrastructure sizing do you need, all of those kinds of things, and to make sure that the whole solution is going to work as expected. But all of these things are really leading up to a quality and a performance standard that we need in production. But all of these are pre-deployment tests. So I'm going to put a big line here, and this will be deploy. And the reason for this is everything is split into two sides. So operationally, everything over here fits into DevOps. And everything here is done in DevOps because the trigger for this is somebody writing code and doing unit testing. So I'm sitting there, I write a SQL script, I deploy that SQL script, put it into the repo, do a unit test, do some integration testing, push it into a lifelike environment, do some performance testing against it, and then I get to this stage and I can see what's changed. I can see that it's of a quality, and then I'm going to do a deployment because I'm happy with those things. But this entire thing is a build. And this is triggered by the fact that I've put new work into the system. That will then trigger off my build process, my release process, and blah, 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 blah. And you get to the end and something new goes into production. And at the moment that it goes into production, this side of the world stops because it's now in production. It's being managed by operations. Now, operations can feed back over the fence into your DevOps pipelines. Sorry, not pipelines, into your backlog. So if we discover in production that it's actually running really slowly and it was just something outside of those tests, we'll feed that back, and the project will have to try to improve that, whether it's making a cluster bigger or something like that. But it's separated processes, so those people might be using ITIL to log a issue, and they'll then find problems, and that will then feed back into the project. On this side of the fence, then, we have within the pipeline, not sure why I've got an arrow on there, sorry. Within the pipeline, we'll be doing data quality. And the trigger over this side, I'm going to call it ADF for simplicity. And Data Factory is going to kick off this pipeline every single day, ingest data, run the data quality tests against it, run the data mastering against it, do all of those things that have to happen on your live data, and it's going to record them somewhere. And it's not appropriate to use DevOps for this test. For the most part, you might decide to use it because it's got some functionality in there that you like. But actually, this is triggered by ADF, and therefore, whatever frameworks you use will need to fit in with your ADF pipelines or within your Databricks or your Spark jobs. And the results of those are going to need to be on the operational side of the house rather than the development side of the house, because if I have a data quality issue, that doesn't link up in any way whatsoever to my build or to my commit or to my pull request on the development side. It doesn't link to this sprint of actions. The data quality issue is coming from the fact that data came in that was bad, or some other factor around that data. There might be lots of missing fields. That's not related to my code. That's related to my users or to my systems of record or that sort of thing. And so we want to tie that to the actual pipeline. So on the DevOps side, we've got build ID, and on the ADF side, we've got pipeline ID or run ID. And those are the things that we're logging these things against to say, this pipeline run had this issue and we need to go back and fix it, and we need to fix it for that set of data that was ingested today. And then I'm going to put data mastering in since I mentioned it. And then we'll also have some performance testing on this side of the fence. So operationally, if my pipeline normally takes 4 hours and today it took 7 hours, there's a reason for that. The reason might be we've got twice the amount of data, and that's fine. But that's the sort of thing where the operations team is going to look at it and say, well, this took nearly twice as long. What was the reason for that? What was the root cause? They look at the data. Oh, there's twice as much data today. That's fine. We'll ignore that because actually it did finish running. And, if there were downstream processes, maybe you'd have to manually intervene to kick them off again. That's fine. But if that takes 7 hours every single day for a week, and the data size is not different, something has broken somewhere in the system that needs to be rectified. And that could be a noisy neighbor, it could be the code, it could be any kind of thing that you can imagine, but it needs investigating and fixing somehow. And the fix can either be operational fixes on this side, so it could be a network issue that's nothing to do with the project, so we won't feed that back into the backlog. It could be some code related thing that we've isolated the problem to just that code. Yeah, let's push it back over to the development side, get that looked into and work out what's going on. And you might have a bunch of other testing on the operations side that you're doing. You could be doing sort of end user tests and that sort of thing, but this is all on production data related to the pipeline run. So hopefully that's sort of explained where the tests are running. So I'm now referring to them as operational testing and development testing. And it's really important to work out which side of the fence your testing is sitting on when you're writing that, when you're discussing it, when you're talking between teams. Be really clear. What is the thing that's kicking off the test to actually run? Is the thing that's kicking that testing off going to be a development process in which it's a pre-deployment development test, or is it going to be kicked off by a daily pipeline run, an hourly pipeline run? Is it kicked off by a message coming in on event hubs or something like that? If that's the case, then it's most definitely operational stuff, nothing to do with the DevOps pipelines, nothing to do with DevOps processes. We're not deploying anything. We're not going to fail a build based on the result of an operational test. But we might feed back into the development process. If data quality is bad all the time, that might be because the process needs changing, in which case we'll feed that back. But if the pipeline itself is causing bad data because there's a bug in it, we should have caught that in the pre-deployment tests. So hopefully that's kind of explained this to you. Hopefully you enjoyed the video. If you did, please click like down below, and if you'd like to see more of these things, hit the subscribe button so that these show up in your feed as and when I make them. But thanks for watching, and I'll see you next time.